Hello everyone, this video will talk you through plate boundaries, including the 3 you need to know for your GCSE exam, and a few of the fundamentals that go along with that. So if we're first thinking about plate margins, it's important then to think about the structure of the Earth. So in its simplest form, the Earth has 4 layers. The crust, so the outer layer that we live on, the mantle, a layer of semi-molten rock, beneath which we have our outer core, and right in the centre of our Earth then the inner core. So when we're thinking about plate margins, especially at GCSE, we're thinking about the relationship the mantle has with the crust. So if we take the crust as our first layer and break this down further, we know that we have 2 different types of crust. We have continental crust, and we also have oceanic crust. So thinking about the key differences here between the 2, our continental crust is typically thicker and on average is about 30 to 50 kilometres thick in places. Whilst it's relatively thick, it's considerably less dense when we compare it to our oceanic crust. So on the reverse of that, thinking about our oceanic crust, we would say, well, this is thinner because it's the opposite of continental. To go along with that, it's about 5 to 10 kilometres thick in places. And the opposite of less dense then would be denser. It's heavier crust, okay? And we'll see why that's important in a minute when we look at some plate margins like destructive margins. So if we know that crust, the outer layer that we live on, is broken down into continental and oceanic, and that's one half of the relationship we were concerned of between the crust and the mantle, we need to think about the mantle then. So movements in the mantle and our plate movements are driven by something called convection currents. So convection currents is this conveyor belt movement. The idea that our magma gets heated by the outer core and the inner core and therefore rises towards the top. When it reaches the top, so beneath our crust, cools and spreads along the surface before sinking back down to be heated again. And that movement and that cycle is happening beneath each one of our tectonic plates. And that's the driving force, that conveyor belt movement, that causes our plates to move in different directions. So keeping these things in mind, we can now start to think about, well, what happens to each one of our different plate margins? So if we take a destructive margin first, if we think about what the word destructive means to start with, it means to destroy. So at this plate margin, we typically have obviously 2 plates, but 1 continental and 1 oceanic. Now, it's typically the oceanic plate here that is going to subduct beneath the continental. So let's label these to make this simple. So we've got our continental here and our oceanic here. Now, our oceanic plate here in this case is going to subduct because it's the denser, it's the heavier plate of the 2. So it's this one that's pushed down, which means it's much easier for our continental plate to ride over the top because it's lighter. So in this case, because you've got our oceanic plate being pushed down, we know here then, as part of subduction, that we're going to see a lot of friction here where these 2 plates meet. And it's that friction here then that's going to cause our oceanic plate to be destroyed. And when we say destroyed, this bit of rock here is going to be melted down, okay, beneath the surface, and is now going to generate magma for us. Now, where we've got our magma here, it needs to escape somewhere, and the pressure is building up beneath the ground. And that pressure that's building up forces its way up towards the top of the surface, and then when it reaches the surface over a period of time, it's going to cool and it's going to condense to form us a lovely volcano. Okay. So, yes, we get volcanoes here, but we also get earthquakes too. Okay. The earthquake comes from where these two plates meet. So that friction and the melting here is going to cause us to have an earthquake. Our two plates are rubbing on each other and therefore causing us to have an earthquake. So in this case, friction equals earthquake. Okay, so some really great examples here of things that are caused by destructive margins would be ocean trenches. So for example, in South America, we have the oceanic Nazca plate then being subducted beneath the continental South American plate. So that creates us the Atacama Trench. Okay, so that's a destructive margin. So if destructive means to destroy them, if we compare that to a constructive margin, that's going to mean to build. So in the case of this plate margin, we have two constructive plates, or continental plates, sorry, that are moving away from each other. Okay, so both of these are continental crust. Okay, so let's label those on whilst we go. So in this case, we have two plates pulling away from each other, which means then that all of that magma that's stored beneath in the mantle is able to start to rise and fill the gap that's left in between. So if this magma rises to fill the gap in between, over a period of time, it's going to cool and it's going to condense. And again, it's going to form us a volcano in the gap that's left. Now, not only will that form us a volcano in the gap that's left, it's also going to create us new crust here, isn't it? Okay, so constructive margins here, because they're building, are generating new crust, and in this case it's in the form of a volcano. So a really good example here of a constructive margin would be the movement then between the Eurasian plate and the North American plate then. So these two are pulling away from each other and forming the Mid-Atlantic Ridge. Okay, perhaps one of the best examples then. Let's add that one on. Okay, so that's 2 out of the 3 plate margins then. So the final one to quickly recap is our conservative margins. Now at these margins, we have got no land being created or destroyed. Okay, these are simply just 2 plates that are trying to get past each other. So we can see these margins when we have 2 plates going in opposite directions, or when we have 2 plates that are both going in the same direction but at different speeds. For example, here I could have one plate going quite slow and the other plate going quite quick. Okay, in both of these instances, because they're moving at different speeds, the plates here are still generating friction. So it doesn't matter which direction they're going in. The main question to ask yourself here is there friction? And yes, there definitely is. So in the case of both of these margins, and perhaps it's easier to explain it with this one here with our 2 plates going in different directions, what's happening is the plates are trying to slide past each other, but in the process and in the middle here, we're seeing a lot of friction between the 2. Okay, and as they're trying to slide, often they get stuck. And when they get stuck, the pressure builds up and up and up until gradually one slips or lurches free. So that movement would be called a stick-slip movement. Okay, and it's at that point then when they're trying to move past each other and they stick and they slip and that energy gets released that we see an earthquake occurring. So a really good example of this one would be the San Andreas fault. Okay, this is the one that's been in the news loads over the years and has caused many powerful earthquakes. Okay, so at the San Andreas fault, what we've got happening is the Pacific plate is moving in the same direction as the North American plate, except that is just moving faster. So in the case of this one, when it's hurried to get past the other, it's still generating a lot of friction. And that friction is translated to the Earth's surface then as an earthquake in this case. So only earthquakes at this margin, no volcanoes, because we've got no magma coming to the surface. So these 3 plate margins then are the ones that you would need to know for your exam. Okay. Keep in mind the fundamentals and the basics that we spoke about at the start. And a good test in the exam, if you're ever unsure if an earthquake's created at a plate margin, is to move your hands in the same direction as the plates are going. For example, with the conservative margins, if you try and slide your hands past each other, are the palms of your hands getting warmer? Because you've got friction. And if it's yes, in which case we would see an earthquake. At destructive margins, if you try and slide your hand over the back of another, is the top of your hands getting warmer or feeling some heat? Yes, should be. You're experiencing an earthquake at destructive margins. On constructive margins, we do get some small earthquakes there. Okay, and it's the only one that this technique unfortunately doesn't work with, but it will help you to rule out some of the others. So keep these basics in mind and try and apply them then to some of the examples you've been looking at in class.